This problem looks innocent enough initially, but actually it's going to require 3 different substitutions for us. The first one's rather simple. We just want to substitute u for theta over 3. And then our du there is going to be 1/3 d theta. I have a 4, but that's not helping with the du that I need, so I'm going to multiply d theta by 1/3, which means I also need to multiply everything by 3. Now I can make that substitution. This 4 is not doing any good inside the integrand, so I'm going to move it out to the front and multiply it by the 3 that's there, and that gives me 12 times the integral of cotangent, and then theta over 3 is our u, and 1/3 d theta is du. So now this part is in terms of u. The only thing left is the bounds, and these are theta bounds right here. I need to change them to u bounds so that I don't have to convert everything back to theta in the last step. To convert to u bounds, all you need to do is to take your formula that relates u and theta, substitute these thetas into there. If I evaluate u at pi over 2, then I get pi over 2 for the theta divided by 3. And when you divide by 3, that's the same thing as multiplying by 1/3. So you can see that lower bound is going to be pi over 6. Now I want to evaluate u at the upper bound, which is pi. That's a little bit simpler. If theta is pi, then u is pi over 3. Now everything is in terms of u. However, I don't know what the antiderivative is for cotangent just by recognition. So I need to make another substitution. This is just a trig substitution. Let's change this to cosine over sine. Everything is still in terms of u. These are still u bounds, so we're all right. Now that we have that, we need to make another substitution. We're going to use the denominator, and I'll use the letter v for our substitution. V is equal to sine u, and the derivative of v with respect to u is going to be cosine u. Notice that we have cosine u du already. We don't need a fix. It should be du. We don't need a fix or anything. So this part right here is going to become dv, and then sine u is v, and we have our integral, and we have the 12 out front. Remember that these are u bounds, and now our integral is in terms of v, so we can use this relationship between v and u to find our new v bounds. If I evaluate v at the lower bound, pi over 6, then I'm looking at sine pi over 6. Use your hand trick for that, and you see that sine is 1/2. I evaluate v at the upper bound, which is pi over 3, which means sine pi over 3. Again, using your hand trick, you see that sine pi over 3 is the square root of 3 over 2. And now finally, I have everything in terms of v, and I'm ready to integrate. When I integrate this, I'm going to have 12 times natural log of absolute value of v. We have bounds on this, so we want to evaluate at those bounds and do subtraction. If I evaluate this at the upper bound, then I'm going to have 12 times natural log. I don't need the absolute value because the square root of 3 over 2 is positive, minus 12 times natural log, again, don't need the absolute value, 1/2. And that answer is correct. That's as far as you would need to go on the AP test. I think it does tell you on the quiz to simplify. One thing you can do is to factor out a 12, and that leaves natural log square root of 3 over 2 minus natural log 1/2. If you remember from the properties of logarithms, when you're subtracting two logarithms that have the same base, you can rewrite it as a single logarithm by dividing the argument. So I get square root of 3 over 2 divided by 1/2. When you have baby fractions like that, the baby denominators will reduce each other. So I end up with 12 ln square root of 3. Another property of logarithms says that if I have a number out front, I can send it up as a power. So I could think of this as natural log 3 to the 1/2, because it's a square root, raised to the 12th power. And if you simplify that, you get natural log 3 to the 6th, which I'm sure you could type into your calculator and get a lovely number. But AP test, I would stop here so that you don't make any mistakes in your evaluation. But to match a multiple choice, you would probably go to this one or to this one right here, or maybe one of these.